So first of all, when we talk about hydration, we definitely have to start with how we sweat, okay, and why we sweat. So what is sweat? Sweating is a process of often it's a response to excessive heat or too much of exercise. Okay, heat wants to like when you exercise a lot, when you are in a hot environment, obviously your body also gets heated up in the form of it produces a whole lot more of energy. Now this unused energy has to escape your body. Okay, so sweating is the process of it, of that, like getting rid of excess heat in your body. So why do we sweat? Like when our body in a normal state, okay, it likes to stay near somewhere around 98.6 degree Fahrenheit. Okay, it's not Celsius, the Fahrenheit. So converting into Celsius, that's a different number. Okay, so whenever our body temperature rises, okay, when it starts to go beyond more than 98.6 degree Fahrenheit, that's when we start to sweat. That's when the sweat is released from our body. And why? When the sweat is released, automatically it won't stay wet for a pretty long time. It gets evaporated quickly because of the natural heat that is around in your environment. Okay, and in the process of evaporation, your body cools down. Okay, you get a cooling effect when you sweat and you just rest or just pause yourself for a moment. You'll see how your body cools down. So it's a natural process of your body to cool down, okay, via sweating. So that's the process, the entire process of sweating. Okay, but when we talk about exercise, obviously you will profusely sweat the more you exercise. And if you are exercising out in the sun, out in open, and especially in the months of summers, okay, on heated days and all, this procedure is much more exaggerated. Okay, so you have to make sure that you do not lose up your body fluids and electrolytes just via sweating, because it could be very fatal if not responded or handled in a good way. So that's when hydration comes into play. The entire this chapter of hydration is about how you are going to replenish yourself without going into a situation that is quite fatal. Okay, getting a heat stroke could also be fatal if you are somebody with a faint heart, if you are somebody who are already suffering from some cardiovascular diseases. Heat stroke, a simple stroke can kill that person. Okay, so what are the other factors, okay, apart from your body? Like, why does your body heat gradually rise? Okay, what's the first reason to that? What are the factors which causes this rise in temperature? So there is two different theories to it. One is your heat stress and one is heat loss. Okay, and heat stress is your sun, okay, solar radiation, natural sunlight, which is hot in nature, and it makes your air temperature hot. Okay, the air which is usually just around you, it is hotter in summer days or at daytime. And relative humidity when you are in a humid weather, okay, in coastal areas and all. When you come visit a beach area, coastal area, you can feel that heaviness in the air. Okay, that is humidity. And you sweat a lot in humidity. Humidity is like, if you imagine yourself in a sauna room or in a boiler room. Okay, that's what humidity is. There is heat, and along with the heat there is a heaviness, natural heaviness in the air. Just give me one moment. Yeah. So about heat stress, okay, usually it is solar radiation. Along with that, whatever relative humidity is there, okay, when you are in a central part of your country, like in India, Madhya Pradesh and all, you will get heat stroke, but it is not because of humidity. It is utterly because of the sun's direct radiation. And then metabolic heat production. In summers, your metabolism is quite high. Your metabolism drops down during monsoons and winters. Okay, so naturally your body tends to get heated up within a short span in hot days as compared to cooler days. Okay, and then you have ground heat. Ground heat won't affect you much if you are within your house. Okay, you are on a floor and you are on a marble floor or granite floor within the house. Ground heat is not going to affect you much. But if you are running or jogging outside, or even if you're brisk walking outside, especially in around 10 p.m. or 11 p.m. in the not p.m. a.m. morning 9 to 11. If you are walking barefoot footed, okay, just outside your home or on grass, even in those times also ground heat can affect you. Otherwise no, if you are inside your own home, ground heat will not affect your body heat level. Okay, then we have heat loss. This is completely heat loss, evaporation, radiation from the body. This is physiological. Okay, like when you breathe in and breathe out, remember this thing, it's not just urine, sweat and feces via which you are using, losing your hydrogen. You lose a whole lot more of water just by breathing. Okay, that's the natural, the air that gets in, the air that goes out. It's not just carbon dioxide or oxygen, it's also other mixture of gases from and within the body. So a whole lot of hydrogen is lost into the atmosphere when you breathe in and breathe out. So that is respiratory evaporation. Most of the water loss that takes place, it's because of your breathing. It's not because of urination, it's not because of sweating, it's neither because of your excretion. Okay, then we have sweat evaporation, that is also physiological. The more you sweat, the more cooler your body cools down. Then radiation from the body, we all emit certain point of radiation. It is very subjective. Okay, when you sit close to, for example, if somebody is lying on the bed, they got up and you came and sat on that particular area where they were lying, you can still feel the heat what they had emitted. Okay, that is the radiation from the body. Okay, and even if you are somewhere very close, sitting very close to a person who is very feverish, you can slightly feel, okay, the area which is very close to that person's body, you can feel the feverish heat emitting towards you. Okay, so that is also an example of how the body radiates heat, thermal energy. Okay, then we have convection from wind current. Sometimes when you are sitting idle and when there is no wind at all, okay, there is no flowing air at all, you feel cool. But suddenly when there is a gush of wind, instead of it being a cool air, it could be a hot air. Usually in the central part of India, in states like Gujarat, Rajasthan, Madhya Pradesh and all, these hot air currents are very common. It's not that common down south or in the northern regions, but in these areas, these hot air currents are very common. Okay, so these are the factors that affect how much do you sweat, okay, how persistently you sweat, and how you can take some measures to combat dehydration because of this kind of sweating. So next, coming to how much of the fluid do you lose? Just by looking at this graph, okay, just notice how the lines are going. Okay, if you just notice this graph, just remove all the wordings, okay, out of this graph. Just notice the x-axis, y-axis, and the graph formation. What do you like? What do you infer from this graph? Is there a positive correlation or is there a negative correlation based on how the graph is acting up? Don't read anything on this. Okay, just try to imagine an empty graph, but the line which is provided here, the same line is the only thing that is present. What do you infer from this? Is there a positive correlation or is there a negative correlation? Is it directly proportional or is it inversely proportional, x-axis and y-axis? On y-axis, you have performance, and in x-axis, you have hypohydration. So this is an inversely proportional. It's not directly proportional. It is inversely proportional, which means there is a negative correlation. Okay. What happens in terms of positive correlation? If you have your textbook, okay, just turn on to page number 143. Okay, there is a graph on the right side, figure 7.2. Can you see that? Please answer in the chat box. Do you have the textbook? Do you have 143 page number open? And if can you see the figure which is there on page number 143, figure 7.2, the graph that is on the right side of the column. Okay, that is a graph which you can call directly proportional. That's a positive correlation graph. Okay, but the one you see here on this slide, it is a negative correlation. So when a graph from point 0, when it rises upwards, okay, it's like climbing up a mountain. Okay, when it rises upwards means there is a positive correlation. What it means, something in the x-axis is increasing, along with that something in the y-axis is also increasing. Both the axes are increasing their data. That's when you get a climbing up the mountain kind of vibe from the graph. Okay, but here it is just the opposite. Okay, something in the x-axis is increasing, but the y-axis it is decreasing. Okay, so that is the relation between performance and hypohydration. What can you infer from this graph is that when your body goes into the stage of hypohydration or dehydration, you can also call it as dehydration, what do you think, how do you think it will affect your performance? How do you think it affects your performance? You can see here from like when the dehydration level was just 1. Okay, you can see the performance was 100. When dehydration level was around 5, okay, just go up, you can see the performance came down to 70. Okay, so that's how you read a graph. Okay, place a point in x-axis and see where it is forming its relation with the y-axis. Okay, and as soon as you go side by side on the x-axis and see how it is forming the relation on y-axis, you can see as this number goes higher and higher, the y-axis number is coming lower and lower. So what do you infer? When you get dehydrated, when you go onto the track of dehydration, more and more dehydration or more and more hypohydration, an athlete's or even a general person's performance level falls down. That's the conclusion here. So that's the reason why hydration, the topic of hydration, is of utmost importance, because it's not just about maintaining a performance level. There comes a stage in dehydration where you will actually see these phases of mental confusion, uncoordinated movements, delirium. Okay, you collapse. In some fatal cases, there could be also be actual death. Okay, just give me a moment. Okay, so like there are techniques to understand what is the hydration level. That's a calculation about aspect of that. We'll come to that later. But one of the most common technique what you can teach others and you can yourself judge on a daily basis is the color of your urine. Okay, the color coordination what is given here on top, it is the most peachish lightest. Okay, it is almost pale straw colored and almost clear. Okay, the top one, the top portion of being well hydrated. Okay, when you come down in severely dehydrated, you can see the contrast. Okay, when there is a stark difference in your urine color, when it turns more yellower and more brownish ochre in color, it means your body is dehydrated. Okay, so this is a you can follow the same urine analysis. Even if you search in Google, you will get various measures somewhere very close to this particular chart. Okay, but you can make an understanding out of it. Okay, up till what level you are hydrated and after what level you are dehydrated, and when you require a medical attention, when it is in case of severe dehydration, that's very critical. Okay, you have to get admitted in the emergency or in the ICU. Normal dehydration you can treat it at home, but when it is a case of severe dehydration, okay, you will require parenteral nutrition, that is IV fluids. Okay, so that kind of care can be given, that can kind of medical attention you can get only from a healthcare system. Okay, so up till this area, from well hydrated to dehydrated, this particular segment you can treat at home, okay, with sports drinks, energy drinks, water, juice, whatever. But after that, if a person goes beyond that, when the urine output, okay, when in case of severe dehydration, this area you will not find urine output. Okay, the body goes into a stage of enuresis, that is no absence of urination, because the body is trying to hold on to as much of water molecules as possible. So there will not be any urination in the final stages of dehydration. Okay, so coming to how much fluid one may require during, before, and after. Okay, so based on your body weight, you can do this calculation, whatever kind of exercise you're going to do. Okay, but in this particular chart is themed around sports personalities and athletes. Okay, because the amount of exercise they are going to put in on a daily basis. Okay, so ideally 5 to 10 ml per kg of their body weight, that much amount of water they have to consume, or fluid, not just water, plain water, or fluid, fruit juices, smoothies, or even any water rich fruits like watermelon, strawberries, melons, okay, cucumbers, etc. Okay, consume that at least 2 to 4 hours before your exercise, and that is the amount how much you have to consume. It completely depends on a person's body weight. During exercise, sip, you have to sip, you do not have to gulp down the water. Okay, during exercise, even if it is 1 hour, you have to sip through the water, and 0.4 to 0.8 liter per hour of exercise. How much it this here you will not go by the weight, you will just go by how much time you are spending in your exercise. And also you have to calculate your sweat rate. I'll show you the formula for that later. Okay, what formula you have to use to calculate the sweat rate. After exercise, uh, after exercise is the main theme, where you have to follow this water rich food. Okay, before exercise, even if you're not having water rich food, does not matter, but post exercise, okay, along with water, some smoothie, or it's the most ideal thing is to go for some water rich fruits and vegetables, same like watermelon, any form of melons, cucumbers, strawberries, citrus fruits, oranges, okay, which has a lot of water content. Okay, apple, guava, bananas, that won't count. Okay, they are on more of on the carbohydrate and uh, protein aside. But yeah, when it comes to oranges, strawberries, citrus fruits, melons, okay, they come on the category of heavy water content fruits and vegetables. So after exercise, this is what you can follow: 1.2 to 1.5 liter of fluid for every kg of body weight that is lost. Okay, body weight that is lost, I'll show you how to calculate it. Okay, so this is not about, if for example, if somebody is 55 kg, 55 kg multiplied by 1.5 liters of fluid, that will be too much, that is fatal. Not like that. How much body weight you lose after every exercise, you do lose, because that the body weight that you lose is the water weight which was lost in form of sweat. We'll come to that later. Okay, so the before you start your exercise, you can check your weight. After exercise, you can check your weight. You don't have to do it on a daily basis. Okay, when there is a seasonal change, okay, when you move from summer to spring, spring to monsoon, monsoon to winter, when there's a seasonal change, you can do this calculation and then follow this particular amount of water for that entire season. Okay, more or less your body will be reacting in the same way. So the body weight that you lose before, when you do the difference of what your body weight was before you started your exercise, okay, and even before you go for, like, as soon as you complete your exercise, do not go for urination. Okay, don't go for urination. Before you go for urination, again check your uh, body weight. That will give you the correct amount of how much of water was lost exclusively via sweating. Okay, and if you have voided, then you have to calculate it. Okay, it was sweat along with urination, I lost this much of water. Okay, so there will be a weight reduction. Okay, before starting the exercise and after starting the exercise, there will be weight reduction because body loses the water weight via sweating. Okay, so whatever that, it may be 500 grams. Okay, you may have lost 1 kg, 500 grams, 700 grams, something like that. That weight lost multiplied by this particular number, 1.25 or 1.5 liter of fluid. That much amount of water you have to consume. Whatever is the answer that is in ml or liters, that amount of fluid you have to consume after your exercise. That's the thumb rule. Okay, so this is how you calculate your sweat rate. Example is also given, so I don't no need to use calculators here. So first, you as I mentioned, first you have to weight yourself before your exercise. Okay, whatever the weight was, and after the exercise, whatever your weight is. Okay, so there is a change in 1 kg. So the before exercise it was 64, after exercise it was 63. So the person lost around 1 kg. So when you calculate, see, when you Google it, when convert 1 kg into liters, you may find different answers. But when you are calculating on basis of your body metrics, okay, 1 kg is considered as 1 liter. Okay, but for other chemical reactions outside the body, 1 kg, when you translate it into liters, there are some different amounts. Okay, but it will not be exactly 1 liter outside the body, but within the body you have to go by this thumb rule that every 1 kg is equal to 1 liter. Okay, because the osmotic pressures of your body fluids, etc., everything is involved. So that's the reason why we give them the same weightage. Okay, so weight before the exercise minus the weight after the exercise, there is a value. Okay, keep that aside, plus how much fluid were you drinking throughout your exercise. For example, you exercised for 4 hours, you had a sip of water in between, or sip of even sports drink. Okay, that also has to be included. Whatever you had ingested or drank, it has to be calculated. You have to be mindful of that. Okay, so it's ideal to have a water bottle or any container which has this ml markings. Okay, and make sure you drink only that particular fluid throughout your entire exercise routine when you are calculating your sweat rate. Okay, so you will get the exact amount of fluid that was consumed. So how much ml or how much liters of fluid you drank throughout your entire routine divided by how long were you exercising. Okay, for in this case, this athlete was exercising for around 4 hours. Okay, so weight lost plus fluid drank, okay, divided by duration of exercise. Whatever answer you get, that is your sweat rate. Okay, so you have to compensate this particular sweat rate soon after the exercise so that you stay well hydrated. So is that clear how to calculate your sweat rate? Is the formula clear? Okay. The same formula is given in the textbook on page number 146. There is a blue box, fluid calculator. Okay, there is a blue box. You can refer that as well. Shall I move to the next topic? Is it clear? Example is given here on the same slide. Okay, whatever is your weight before you start your exercise, before you start your day, calculate. If you are doing morning exercise, as soon as you wake up, before you set on your exercise, just calculate your weight, do your exercise, come back, don't go for urination, don't go to defecate, Okay, just come back after exercise. Soon after the exercise, don't sit or don't do anything. Just weigh yourself. Just weighing yourself. You see the difference. Plus, how much amount of water or fluid you had consumed during the entire exercise routine. Okay, divided by how much total hours you had spent on exercise. That's it. That's the formula. So you will get how what is your sweat rate. Sweat rate will differ in every season. Whatever your sweat rate was in summers will not be the same during winters. So every day, nobody has to do this formula. They just have to do it once in 3 months or 2 months when you know the season has changed. Okay. Now coming to sports drinks. Okay, because during exercise, before exercise, after exercise, what to drink instead of water to get the better performance level. So sports drink is an answer. Sports drink is not something that you have to spend money on. During the last segment of our this section, we'll see how sports drinks can be made at home. Okay, homemade sports drinks. So yeah, you have usually three different types of sports drinks: hypotonic, isotonic, and hypertonic. From the name itself you can understand what it could mean. So sport drinks, it is how it is different from energy drinks. Energy drinks have caffeine to it. They have some vitamins, minerals, etc. to it. Okay, added flavors. Sport drinks also have added flavors, but the main two aspects of your sport drink is carbohydrates and electrolytes. That's it. Okay, sport drinks does not want to give you anything else. They just want to give you carbohydrates and electrolytes. That's it. But energy drinks, you can add more concoctions to it along with caffeine. That's the main difference. Sports drinks don't have caffeine. uh, Energy drinks, they have a caffeine component to it. Okay, so hypotonic means the concentration of how much carbohydrate and electrolyte is there with respect to the ml of water. Okay, it's very few carbohydrates and electrolytes. Okay, so uh, it will not aid in weight gain. Hypotonic sports drinks will not give you weight gain even though it has carbohydrates. The sole purpose of the carbohydrates is to get absorbed faster than plain water. Okay, it will since it has a little bit of carbohydrates in it, so it has osmotic pressure that is higher than water. Okay, so when you drink the same ml of water, that water will not be absorbed this quickly in your body, but this hypotonic sports drink will be absorbed very quickly by your body. And if it is absorbed quickly, the sooner you will get use out of that carbohydrates. That carbohydrates will not give you weight gain because you are working out. Okay, you are doing some exercise routine and you require a quick pick me up energy, and this hypotonic sports drinks can give you that. Coming to isotonic, they have around 6 to 8 percentage of carbohydrates electrolyte ratio as compared to plain water, and they can quickly replace the fluid that was lost by sweating. Okay, it will replenish the cells, your body cells soon. And it is usually used by athletes, footballers, okay, basketball, those who are playing this contact sports. Okay, and not like for cricketers and all. For cricketers, they may require much more glycogen stores because like when you see look at cricket as a sport, it has a much more longer duration as compared to basketball, football, etc. Okay, so football, basketball, etc., there are very short duration games. So yeah, for that, isotonic sports drink is the ideal one. Hypotonic is only for people, for ballerinas, okay, gymnasts, jockeys, those who are in this polo jockeys. Okay, they want to maintain a very low weight. Okay, because they are climbing horse, and if they are heavy, it may affect the speed of the horse, etc. So yeah, along with that, gymnast and ballerinas, etc., ballet dancers, okay, they have to maintain a specific weight so that their movements are very light. Okay, whenever they're doing certain postures, jumping around, okay, their body has to be very feather light, and they want the energy to do the jumping and everything without gaining weight. For them, hypotonic sports drink is the ideal solution. Then finally we have hypertonic. Okay, this is to supplement your carbohydrate intake. It will not be absorbed very quickly by your body. So people who go for this marathons and cyclings and all, okay, for a prolonged period of time, you are not supposed to get off your machine. You are not supposed to get uh, off your sports lane. Okay, and you have to go a bit longer before without food, but you have to make sure you have enough energy. You should not get hungry in between. In such cases, go for hypertonic, because the amount of water used will be very less, but the amount of carbohydrates and electrolytes which are present in the hypertonic, too much of concentration of carbohydrates and electrolytes are present in this will not be absorbed quickly by your stomach. It will stay in your stomach for a pretty long time. Okay, somewhere very similar to bread or an omelette, something like that. Okay, and it will slowly give you energy throughout the entire sporting event. Okay. So energy drink versus your sports drink. So energy drinks, they contain sugar, they have caffeine, they have plant extracts. Sometimes it is like Goa flavored, apple flavored. Okay, they also have some uh, caffeinated herbs. Okay, some specific kind of trees, relaxing trees, chamomile drink or lavender essence, something like that. Okay, so some essences will be there, like ginseng, amino acids, okay, some amount of protein, vitamins, antioxidants. Okay, so it's a concussion of a various amount of functional nutrients. Okay, and they are considered as a dietary supplements. They are not just supposed to give you carbohydrates for energy, but they're also there to help you in other areas of your nutritional health. So that is the reason why we consider energy drink in the same category as dietary supplements. And it is not approved by FDA. Anyone can make any flavored energy drink. Okay, they are not research backed up. Energy drinks are not research backed up. But when you come to sports drink, there the main content of sport drink is carbohydrates, sugars, or electrolytes. Okay, and they are categorized as food because they are supposed to replace your food in certain cases. As I mentioned, the hypertonic sports drinks, okay, they are supposed to replace the food when the athlete is on a very long run, marathon, cycling, etc. And they have, FDA has a very strict laws for the manufacturers and for the producers and the distributors of sports drinks. There are specific like why they have this strict law behind sports drink is that it is rampantly used in the sports community, and we do not want any performance enhancers be mixed with sports drinks. Okay, sometimes the energy drinks can get away with some performance enhancers like caffeine, etc., but in sports drinks that is not the case. Okay, so this is the main difference between energy drink and sports drink. Is it clear to all? Next, coming to the concentration of sports drink. So like, as I mentioned earlier, when you make a sports drink at home, okay, you just require water, a real fruit juice, okay, without sugar, real fruit juice, without any added preservatives or artificial colors. Okay, and you require a pinch of salt. Why salt? Okay, why salt? Because it salt has sodium, and sodium is a very important component in your sports drink. Why? Because just imagine you had rice, dal, and you were heavy handed on the usage of pickles. Okay, the typical Indian pickles, not the sweet ones. Okay, they are salty and sour ones. Okay, what do you think your water consumption will be after that, after indulging in this pickle or any snack that was heavily salted throughout the day? What would your water consumption be? Yes, salty food will make you thirsty. Okay, it will make you thirsty. so what sodium is doing here is it is creating the urge in the person who had this sodium intake to drink more. Okay, so that is the reason why we focus more on sodium in sports drink. It makes the person drink more, so a direct effect of that is the person will stay hydrated. Okay, so that is one of the reason. Again, sodium will not um, sodium causes water retention in the body. Okay, it will try to reduce the water lost by urine. It will effectively enhance sweat, but it will not allow water to be lost more from the urinal side. Okay, even after having sodium, one can still sweat, but the loss of water from urine is reduced, but it is translated into sweat. That is on the healthier side, and it creates this urge in the sports drinkers to drink more. Okay, they want more and more, and the taste is also something like that. They will look forward to drinking that, completing that bottle, okay, by the end of the exercise. So that is one of the reason why sodium has this importance in sports drinks. Then we have carbohydrate, another major component. So it will give you a quick energy, since it makes your sports drink taste sweet. And you can add some artificial flavors when you buy, when you go for a store bought sports drink. It is artificially flavored, so it enhances your taste. Okay, and since it has carbohydrates, when you compare the absorption of plain water and a water which has a little bit of sugar, okay, or carbohydrates, the one that has sugar will be absorbed quickly by the intestine as compared to plain water. Okay, so along with hydration, it is also giving that quick calories, so that one will not deplete their glycogen stores. Okay, and the most, see, what kind of sweetener can you use in uh, a sport drink? Okay, maltodextrin. Maltodextrin in other cases, okay, apart from sports drinks, in other cases like in some junk food or packaged food, okay, it's a very notorious kind of polymer, glucose polymer. Okay, why it is glucose polymer? And it is somewhere in between your classic glucose and starch. It is somewhere in the mixture of a starch and glucose, so it's a glucose polymer. Okay, but when we talk about sports drink, maltodextrin is highly effective. The reason why, when you compare all these concentrations of different concentrations of glucose, fructose, and maltodextrin, okay, what do you think has a higher concentration but a very less molecular size? Just by looking at the image, okay, you compare 6% of glucose, 12% of glucose, okay, 6% of glucose plus fructose, and then 6% of this polymer maltodextrin. Okay, the amount of water used is same in all these cases. The concentration changes only when you add more of glucose, less of glucose, something like that. What do you think is the concentration level, like which has the lowest concentration level, which has the lowest carbohydrates or lowest concentration level? When we talk about the concentration level, glucose as well as maltodextrin, okay, they are in lower concentration. Okay, but the amount of calories, because maltodextrin is a polymer, it has the calories of starch as well as glucose. Glucose has only the calorie of a simple carbohydrate. Okay, maltodextrin has a calorie of starch as well as a simple carbohydrate. Okay, so you are given an option of having 250 ml of maltodextrin drink, or if you want the same amount of calorie which this 250 ml of maltodextrin can give you, you have to go for 500 ml of glucose drink. Okay, and this is a sports event where you can't take a lot of bathroom breaks. Which will help you? Will the maltodextrin help you, or will the glucose solution, which was 500 ml, which gives the same calories, that will help you? Yes, it is maltodextrin. So this is the reason why maltodextrin came into the sports industry. Okay, it can give enough amount of calories, but at very lower concentration. Okay, just imagine you take 50 ml of water, okay, at home. Just imagine you're taking just a 50 ml of water, that is not even half a cup, okay, and you are mixing 2 whole tablespoons of sugar in that, in 50 ml of water, and try to drink that. Is it possible for you to drink it? 50 ml of water with 2 whole tablespoons of sugar, you have diluted it. Okay, what is the consistency? Is it easy for you to drink it down, gulp it down? No, it will not be. Okay, just imagine 50 ml is just, yeah, sugar concentration is so much. You will, when you try to drink it, you will feel nauseous. Okay, you will feel like vomiting out. Okay, the consistency will be very sticky, it will be very slimy, it's not palatable, okay, for humans consumption. It will be very syrupy in consistency, etc. You will not feel like having it. But instead of the calorie that 2 tablespoon of what sugar can give, okay, a little bit, a pinch of maltodextrin in that same 50 ml of water, you can easily chug it down without any without knowing the taste component of it. It is not that sweet. Okay, it's not that sweet. So that is the reason why maltodextrin came into existence. Okay, in very less concentration, it can give high carbohydrate without affecting the taste. Okay, and without affecting the without putting the athlete into too much of water consumption. Too much of water consumption just to get calories through sports drink is also bad for the performance. Okay, so that's how maltodextrin helps. So real fruit drinks, this is how you can make at home. Okay, if you do not want to spend your money on artificial drinks, or you do not want to pile up on plastic waste and all, because see, when you buy sports drink, you are causing some kind of damage to the environment in the amount of plastic bottles you may be consuming. Okay, or even cans you are consuming. So if you just switch on to using your own sports drink, you can control the flavors of it. You can seasonally just go for the food seasonally that are available. Okay, the only thing you require is 250 ml of water and the same amount of pure juice, pure 100% juice, in the sense no added flavors, no added sugars. Okay, cold pressed juice, that is highly ideal. Okay, without adding any water component. How much over juice you can get out of a fruit? Take 250 ml of that, 250 ml of water, and a pinch of salt. Pinch of salt in the sense between your thumb and your index finger. Okay, when you try to hold a salt between your thumb and index finger, how much salt will come in your thumb, in that thumb and index finger, that's the pinch of salt. Okay, so that's how you can make your own sports drink. And about caffeine, yeah, caffeine can improve the performance, because when you read about the studies which are given here in the textbook, when you come across the caffeine area, caffeine can obviously give you energy. It can make the athlete more alert. Okay, to an extent, it can make the athlete more alert and focused. And even after the sports event, when you are trying to rehydrate yourself, okay, some people say that don't depend on tea or coffee for rehydration, it can cause more dehydration. No, it's not true. Okay, to an extent, exact amount is also given in the textbook. Okay, when you are having caffeine to improve your performance or just for rehydration, okay, you can just go up till 400 mg of caffeine. Any drink that has 400 mg or 350 mg, 450 mg of caffeine, it's completely fine. Okay, it's completely fine. And but if you do an overdose of caffeinated drink, that's when it will be an issue of dehydration. Then alcohol during performance, don't go for alcohol for hydration purposes. When you are not on your training days, when you are not training, when you are not exercising, okay, when you do not have any events, sports events coming up, at that time obviously you can indulge in alcohol. The amount of alcohol, how much you can have per week, like it is 14 units per week you can have, it is completely healthy, normal. And some amount of wine on a daily basis, not on performance days but on other days on a daily basis, can prevent cardiovascular diseases as well. Okay, so keeping that in mind, but it is highly advisable to avoid alcohol at any cost, a day before or during your any sports events. Okay, the metabolism of alcohol is given here because alcohol is something that can directly enter your bloodstream within 30 seconds of your consumption. Okay, and it stays in your system up till 12 hours, and it will travel through not just your bloodstream, your pancreas, your liver, your intestine, through all these major organs. Alcohol will travel because, yeah, within 30 seconds it is getting into your bloodstream. So with the help of the bloodstream circulation, it can travel through all your major organs. Okay, so that is the reason why after consuming alcohol, if you try to do any sports event, you will not make a focused decision. You will not make a decision based on clarity. Okay, it could be a very disoriented decision. Your body could be very disoriented. You may be mentally alert, but your body may not compensate that alertness. Okay, so that is disorientation. So avoid alcohol consumption at any cost during sports events or before that. And also try not to do any if you had a drink or few for a party or something, you drank heavily, the very next day you will definitely get hangover. So try avoiding any exercise routine, any training, any endurance exercise, any exercise of any sort. Try avoiding that on the hangover days. Okay, and definitely you can depend on sports drink, okay, without caffeine, sports drinks without caffeine. Okay, you can depend on this uncaffeinated sports drink to give you hydration, because your body will be definitely dehydrated after alcohol consumption. Okay, so instead of plain water, try to make a sports drink at home or buy a sports drink and have it to get over your hangover and dehydration post consumption of alcohol. Any doubts if you have, just mention in the chat box.